Hello everybody. First of all, I have no words to say. It's a big honor to be here with you. Thank you for everything. Comments on Facebook, TikTok, YouTube, which exceeded my expectations. I promise I will do my best to achieve success together. So keep watching, stay tuned, and let's start our topic. In this video, I'm gonna talk about the elements. The previous video, we talked about atoms, and we could know everything related to atoms, like a charge, like mass. But today, we have the elements. It's very important to know everything about elements. So I can say atoms form elements. Elements participate in chemical reactions and form compounds. And now you need to be familiar with elements. What is the number of elements in our life? We have 118 elements, and scientists arrange them in the periodic table. So if you don't have the periodic table, please go to Google Images and print one. It will help you a lot. It's very important to have it. And also scientists tell us about the types of elements. We have two different types of elements. The first type contains 111 elements and the second type contains 7 elements. Let's talk first about the first type of elements. The first type contains 111 elements, and this number is similar to the number of Telecom Egypt, we. So let's make a call. Okay. Hello? I have a big problem. Can you help me? My service is broken down. Can you handle this?
ادي لك ساعة ونص عمال تقول لي شيل الفيشة وحط الفيشة، شيل الكابل وحط الكابل.
Okay, I'm waiting.
افصل الراوتر ورجعه تاني.
And now he's speaking. Please, before talking, I know what will you say. Check the green lamp. I did. Next.
اللمبة الخضراء نورت يعني. أعدي الإشارة ماشي.
Please, my service in danger. Help me.
I am the danger.
That's all. Please don't call him again. Help yourself. So going back to our first type. As I said, in the first type, we have 111 elements. These elements are considered to be monoatomic elements. So what do you mean about monoatomic elements? For example, if you have Na contains similar atoms of sodium. These atoms arrange themselves singly. So if you have a strip of Na, you will get single atoms. That's like iron, like copper, like sulfur. All these elements have single atoms. Keep that in mind. And now let's move to the second type of elements. The second type of elements contains 7 elements. And also this number reminds me the number of World Balls that Messi won before the World Cup. Hello CR7 fans, I'm one of Messi fans and I'm so proud of that. So let's talk about these 7 elements. These elements are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and also we have iodine. These elements are considered to be a diatomic elements. And now what about owning a diatomic element? For example, if you have a sample of hydrogen, hydrogen is considered a diatomic element. As a result of that, hydrogen contains similar atoms, but here these atoms bonded to another to form molecules. And now, if you have a diatomic element, you will get molecules. So, as you can see, we have 2 different types of elements. The first type contains single atoms, and the second type contains molecules. And now, let's move to the periodic table and know a lot about elements. If you look at the periodic table, you will have elements on the left side and elements on the right side. Also, we have elements in the middle, and also we have elements below the periodic table. But today we will talk only about the elements of the 2 sides of the periodic table, the left side and also the right side. So let's talk about the elements on the left side. On the left side we have 2 groups. The first column is called group 1A and the second column of the periodic table is called group 2A. So we have group 1A and also we have group 2E. These elements, unlike hydrogen, are considered to be metals. And now, being a metal, it must has a large atomic size and also it has a low electron affinity. So what do you mean about electron affinity? Electron affinity means the ability of an atom to acquire, to pull an electron outside the atom. And now, because metals have a large atomic sizes, they tend to give away their electrons and form a positively charged particles, or you can say cations. For example, Na as an example for group 1A. Na has atomic number 11. Its electronic configuration 281. Now let's focus on the last shell of sodium. The last shell is also called the valence shell. Sodium has one valence electron, so sodium tends to lose this electron and form a positive one charge. So if you have Na tends to form a cation with a positive one charge. So let's work on another example. Mg, which stands for magnesium. Magnesium is located in a group 2A. So Mg as an example for group 2A. Mg has atomic number 12. Its electronic configuration 2A2. And now we need to focus on the last shell. Magnesium has two valence electrons, so it tends to form a cation, but here with a positive 2 charge. As you can see, the left side of the periodic table can form cations with a positive 1 charge for group 1A, and also we have a positive 2 charge for group 2A. And now to the right we have group 3A, 4A, 5A, 6A, 7A, and also we have group 0. Group 0 contains inert gases, or you can say noble gases. These elements are chemically inert. They don't participate in chemical reaction. So let's focus on group 5A and 6A and also group 7A. The elements in those groups are considered to be nonmetals. And now, being a nonmetal, it must has a small atomic size and also it must has a high electron affinity. So nonmetals tend to acquire electrons and form a negatively charged particles, or you can say anions. Example, Cl. Cl, which stands for chlorine. Chlorine is found in a group 7A. Chlorine has atomic number 17. Its electronic configuration 287. So let's focus on the last shell. The last shell or the valence shell contains 7 valence electrons. So chlorine tends to get 1 electron in order to be 8 and form a negative 1 charge. And now let's work on another example. Oxygen as an example for group 6A. Oxygen has atomic number 8. Its electronic configuration 26. So oxygen has 6 valence electrons. It tends to get 2 electrons in order to be 8. So oxygen can form an anion with a negative 2 charge. And here is another example. If you have nitrogen. Nitrogen is an example for group 5A. Nitrogen has atomic number 7. Its electronic configuration 2, 5. So nitrogen tends to get 3 electrons in order to be 8. So on the right we have nonmetals, or you can say anions, in group 5A with a negative 3 charge, and group 6A with a negative 2 charge, and also we have group 7A with a negative 1 charge. And now we didn't talk about the group 3A and group 4A. Group 3A contains metals like aluminum, has atomic number 13, its electronic configuration 283. Aluminum tends to form a positive 3 charge, but in that group we also have something called metalloid like pearl. So let's focus on metals on the left side like group 1A, 2A, and non-metals on the right side. They are located in group 5A, 6A, 7A. Now if you see group 4A contains non-metals like carbon and also contains metalloids like silicon. So let's focus on group 1A, 2A on the right. Let's focus on group 5A, 6A, 7A. And now you have cations on the left side and anions on the right side. So combine together you will get ionic compounds. So I could say the ionic compound is usually formed between the elements of the two sides of the periodic table, cations and anions. And now if you have a cation and an anion, you will get ionic compound. Now let's work on an example. If you have a formula like NaCl. NaCl contains Na, which located in a group 1A, and also you have Cl, which is located in a group 7A. So you have a cation and also you have an anion. Na cation, and also you have Cl as an anion. And also MgO. MgO as a formula contains Mg, which stands for magnesium. Magnesium is located in a group 2A, and oxygen is located in a group 6A. So if you have elements of the two sides of the periodic table, you usually get an ionic compound. Now let's move to the rules of naming an ionic compound. It's too easy to name an ionic compound. The only thing you need to do is add the suffix IDE to the non-metal. For example, if you have NaCl and you need to name this formula, the only thing we need to do is add the suffix IDE to the non-metal. So Na, which stands for sodium, Cl, which stands for chlorine, adds a suffix IDE, and instead of saying chlorine, it's gonna be chloride. Combined, you will get sodium chloride. Let's work on another example. If you have MgO, Mg, which stands for magnesium, O, which stands for oxygen, the only thing you need to do is add the suffix IDE, you will get oxide. Combined, you will get magnesium oxide. So it's too easy to name an ionic compound, but I will talk about the whole rules of naming ionic compounds, inshallah, in the next video. So thank you for watching. See you later. Bye.